Y'all, happy Wednesday. Today we're going to we've done translation reflections. Now we're going to focus on rotations, more specifically just the idea of 90-degree rotations. Okay, so I'm going to go ahead and jump in straight into my idea of notes. You can write these down if you would like. I'm just going to fill in the blank as I read. Okay, so a rotation is a rigid transformation that rotates or turns a figure through a given origin or in a given point around, or a given location around a fixed point. Sorry, I blanked there for a second. The point is called a center of rotation. Okay, so when you are rotating around a fixed point, it's our center of rotation is what we're rotating around. Okay, so here are some rules that I remember when I am doing 90-degree clockwise or counterclockwise rotation. Okay, so if you are given a part, your original x and y, so let's just give our original x and y, let's call it, let's say we're at x is 3 and your y is 2. Let's say that's our original point. Okay, when we do a 90 degrees clockwise rotation, your new x, your x prime, is the same as your original y. Which means for our new point right now, we are looking at your x as now a 2. Okay, your original y was 2, so your new x is 2. Your new y, okay, your y prime, your new y is the same as your original x, but flipped sign. Okay, I like to just use a negative as that example, but it's flipping. Okay, so for instance, this is a positive 3, so your new y is going to be a negative 3. Okay, that is how 90 degrees clockwise works. Let's say your original x was negative 3. Your new y is going to become a positive 3. Okay, it literally is just changing signs. Same idea works now. Let's say we are doing the exact same coordinates. Let's say now we are looking at, still 3, 2 for your original x and y. But now we're doing 90 degrees counterclockwise. Okay, counterclockwise. Your new x is the same as your old y, but now that's flipping signs. Okay, which means our new x, we're looking at a positive 2, is now going to be a negative 2. Your original y was 2, so your new x is negative 2. Your new y, your y prime, is the same as your original x, which means your original x was 3, your new y is also going to be 3. And that's where your new point's going to go. This is the rule for every single vertices on your shape, okay? Every single vertices. Those are our rules. So I would recommend you write these down, right? 90 degrees clockwise, x prime is the same as your y prime is the same as your original x flipping sign. 90 degrees counterclockwise, x prime is the same as your y but changing signs. Your new y is the same as your original x, okay? I'm hoping this makes sense. If it doesn't, please let me know, but I would write these down in your notes, okay? Now that we have rules, I would like you to go ahead, well, I guess I can give you an example. I hope I don't run out of time. So make sure you first identify where your vertices are, all right? And then I would also, since we're doing clockwise, I would write down, or we're doing rotation, I would write down where these are at. So this is negative 4. Sorry, it's going to look a little wonky. 5. Your R is at negative 4, 1. And then your, let me close these parentheses. Your S is at negative 2, 1. Okay, so if we're going to do 90 degrees clockwise, right, remember our rule, no matter what they're flipping, okay, no matter what, your x and y are going to be flipping for your new point. So I automatically know that my Q is going to become 5, negative 4. But remember, one of these has to change its sign based off if you're going clockwise or counterclockwise. So if we're going clockwise, your new x is going to change. So it's actually going to become a positive 4. So over 5, up 4, there's our new point for Q prime. Okay, our new S is automatically, I already know it's going to become 1, negative 2. But again, we're going clockwise, so your new Y is actually going to become a positive. It's going to flip signs. Okay, over 1, up 2. I'm running out of time. Watch the next video. I'm going to continue.